All right, if you're serious about becoming a Python developer, I mean really serious, then this is one of the most important explainers you're going to see. We're going to cover the one concept that truly separates simple little scripts from professional, large-scale applications. Okay, let's get right into it.
So just think about it for a second. How on earth do apps like Instagram or Spotify keep millions of lines of Python code from becoming a complete and total nightmare? I mean, it's not magic, right? It's all about architecture. And the answer is actually surprisingly simple, but it's also incredibly powerful.
Yep, that's it. That is the secret. Modules are the absolute bedrock, the fundamental building blocks of pretty much all real-world Python software. And by the end of this, you'll know exactly how to use them like a pro.
So let's start with the absolute basics. We're going to pull back the curtain on these secret building blocks and really get to the heart of what modules are all about.
It really is that simple. Don't overthink it. A module is just a Python file. Any file that ends in .py. Anything you decide to put in that file, a function, a variable, a class, can now be picked up and reused anywhere else.
Let's make this super concrete. So imagine you create a file, let's call it math.tools.py. Inside, you just write some simple math stuff, maybe a function to add two numbers, and you define the variable pi. And boom, just by saving that file, you have created a fully functional Python module. It's now this little self-contained block of code, ready to be used wherever you need it.
So why is this so critical? I mean, why do we care? Well, because modules force you to be organized. They let you reuse code without that terrible copy-pasting we all do at the beginning. They keep different parts of your program clean and separated. And honestly, they're the only way to write professional software that can actually grow and scale.
Okay, so you've created this cool module. Now what? How do you actually use it in another file? Well, that's where importing comes in. The best way to think about it is like opening your coder's toolkit and just grabbing the specific tool you need for the job.
So you've basically got three main ways to do this. First, a basic import. This is like grabbing the entire toolbox. Then there's a specific import, where you just grab one single tool you need, like the square root function. Or, and you're going to see this one everywhere in professional code, you can use an alias import, where you rename something to make it shorter, like changing NumPy to just NP. This is a total pro move to keep your code clean and super readable.
Now, here's the cool part. Python gives you a huge head start. It comes packed with a massive standard library of modules that are ready to go. But the real power, that comes when you start building your own. Let's see how that works.
Right out of the box, Python hands you these incredible tools. You've got the math module for any kind of calculation, random for when you need, well, randomness, and datetime for handling anything to do with dates and times. And these are just a few examples of what's at your fingertips before you even install anything else. But this is where you really level up. Making your own module is just a simple three-step process. 1. Create a file, let's say calculator.py. 2. Add your code, your functions. And 3, in your main program, just import it and start using it. This little loop right here, this is how real applications are built, piece by piece, module by module. Okay, now that we have the building blocks, let's talk about scaling up. We're getting into the techniques that really separate the beginners from the pros. We're talking professional-level organization and reusability. So once you start creating a bunch of modules, you need a way to organize them, right? Otherwise, it's a mess. And that's exactly what a package is. It's just a folder that you use to group related modules together. It's like going from one messy toolbox to a beautifully organized set of drawers. Okay, everybody listen up, because this next concept is probably one of the most important tricks in all of Python, and it comes up in interviews all the time. You'll see this line of code everywhere, if_name equals _main. Here's what it does. It allows a single file to do two different things. If you run the file directly, all the code inside that if block will run. But if you import that file as a module into another script, the code inside that block won't run. This is absolutely essential for creating tools that you can reuse without them accidentally running code when you don't want them to.
All right, let's bring this all home. We've talked about the what and the how. Now let's talk about the best practices, the things that will really define your career as a Python developer.
Think of these as the rules of the road. Keep your modules small and focused. Each one should do one thing and do it really well. Give them clear names so you know what they do. And please avoid circular imports. That's where module A imports B and module B imports A. It's a recipe for disaster. And that /name equals /main trick we just talked about, that helps with that last point.
So why does all this matter so much for your career? Because a deep, solid understanding of modules is foundational for over 90% of Python jobs. It doesn't matter if it's web development, data science, automation, modules are the backbone of everything.
And I really want to leave you with this thought. This isn't just a nice-to-have skill, it's an absolute necessity. Without a firm grip on how to structure your code with modules and packages, trying to build any kind of large-scale application is, well, it's basically impossible.
So as a final check, take a look at these questions. These are the exact kinds of things that will come up in a technical interview. If you can confidently answer them, you are in a fantastic spot. And based on what we just covered, you know a module is a file and a package is a folder. You know that _name == main trick, and you know the different ways to import. You've built a really solid foundation.
So there you have it. You now understand the fundamental principle of Python architecture. You've just been handed the architect's blueprint, the same one used to build these massive, world-class applications. So, the only question left is, what are you going to build first?